In this lecture, I'm going to talk about key management. This is a lecture series of cryptography, network security, and cyber laws. This is module number 3. In this lecture, I'm going to talk about the introduction towards key management, what is digital certificates, and a standard format of X.509 certificate, what is certifying authority, what is public key infrastructure, different architectures of public key infrastructure, and so on. Let us see what is key management. Before studying what is key management, we have to understand. Until so far, we have not given any importance towards the key or the authentication. We used to talk about message confidentiality and privacy using various cryptographic encryption algorithms like data standard encryption or RSA encryption and other encryption schemes. But now the key used for those algorithms, where the key will be generated, how the key will be generated, and how it will be maintained. That is what exactly called as key management. The process of generating the keys, storing the keys, and distributing the keys, and also backupping the keys is called as key management. There are certainly three possibilities that can be maintained with the help of key management. The first possibility is the sender may keep the key of the receiver and we call the key as public key. The second possibility is the sender will not store any key. The receiver will also not store any key. The keys will be maintained by centralized authority. The third possibility is sender receives a documentally signed trusted source containing the receiver's public key, and we call the document is called as certificate. We'll see the detailed aspects of certificate or the digital signature in the later section. What is digital certificate? It is same as of your normal certificate. It's a this is a layman example which I'm going to explain now. If you would have attended any workshop or if any competition, you will receive a certificate saying that this is a person and he's attended the conference or workshop or participated in any sports activity or and all, and that will be countersigned by respective authorized signatures, authority people. That is called a certificate. And here also, if you want to call a digital certificate, that also has to be authorizedly signed by respective people. The signature will be not in the fashion of normal signature, and we'll call it as digital signature. Hence, electronic credentials used to assert the online identities of individuals. It might be computers or mobile or a network or a router, whatever, and it is called as digital certificates. It is similar to ID cards like PAN cards or passports or a driving license. Why we require all these identification cards? The reason is that to identity, it's an individual identity of individual person. To make sure that I am a unique person and I have my ID card, and to showcase that ID card in front of the authorized people or wherever it required. In the similar way, if you want to use any kind of networks or a computer or troubleshooting anything, that can be done with the help of authorized certificates, and that certificate is called as digital certificate. And who is going to provide the digital certificate? That will be provided by centralized authority. In the same way, in case of who is going to provide the deal, there will be RTO officer. Or who is going to provide the passport, there will be authorized person. Who is going to provide any certificate, that will be provided by respective authorized person. In the similar way, this digital certificate is also provided by a centralized authority. We can call it as certifying authority or certificate authority, commonly called as CA. He is the one who validates the certificates. He is the one who gives the certificate for respective usage. There will be a situation where some cases we'll commonly use a word called a self attestation, right? In the same way, here also we have a possibility of self-signed certificate, and that will be not in the greater demand, and that will be not in the usage of all over the public network, and that will be used only by the authorized people again. Some of the examples of who is going to give the certificates and all, some of the examples of trusted third parties are something like semantic.com or godaddy.com and all. They are the centralized authorities authorized by government of India. They used to provide certificates for respective people who they want to construct a network or they want to use some set of computers and all. The better example, certificate example is X.509 certificate. It actually developed in 1988. It's a series of 8 X.500. It's a series 501, 500 and all. X stand for it's a certificate, so they given it as X dot. It's a number version, and we have it's a unique number 500 series, and we have various versions: version one, version two, version three, and it is developed actually the version 3 is developed recently, and it actually developed in 1988, and it also comes under public infrastructure. Let us see the stand, and it was developed by ITU, called as International Telecommunication Unit. And let us see the standard format of the structure of the certificate of X.509. The certificate consists of the first field as version. Version, as I said already, we have three versions: version 1, version 2, and version 3, followed by the serial number, that is unique number. It's a integral unique value that will be given by certifying authority, followed by the signing algorithm. Like we had studied already, what is RS algorithm. In the same way, commonly used algorithm for signing signature algorithm is RS algorithm. And issuer name, the name of the issuer who is going to provide the certificate, and period of validity. This consists of again two subfields. One is from, and the other one is to. That is the end, start of validity and end of validity, followed by subject name, the name of the issuer certificate for which he wants the certificate, followed by the public information, followed by issuer unique ID and subject unique ID, and extensions consist of ID and other values, and followed by the signature. Let us see an example for the format what we saw. In the example, the version is 1, serial number that given with some hexadecimal number, signature followed by some RS algorithm, encryption algorithm, issuer name followed by email address, followed by the validity, that is from date and to date, and subject why he required that certificate, followed by the public information, followed by the long modulus value, and at last followed by signature of the algorithm. And once the certificate will be issued to the respective user, or it might be for the respective organization or institution, and how it will be generated and how the process of certification will be done can be seen in the next architecture, and I'll call it as how digital certificate works, or digital certificate in action. Whenever the user want to receive, or whenever he wants a certificate, he has to send a request to certifying authority. As I said, they are the person. As we apply, if I want to apply for any DL, where we have to apply, we have to take an application form from the RTO, and we have to apply. In the same way, as we require the certificate, we have to apply to the certifying authority, and the process will continue as this. Whenever the user applies for a request for certifying request to certifying authority, he has to provide his public key, and he has to provide his identification, user identification. The certifying authority job is, the next step is, to certifying authority has to verify whether the user is a valid user or not. Whenever the certifying authority assures that he is a valid user, he build a certificate for the user. This is the third step. Whenever the certificate is built by certifying authority, and that certificate should be attached with some signature, I mean to say the RTO signature is required, right? Whenever the DL is given, that DL is attached with the signature of the RTO officer. In the same way, here also, the once a certificate is generated by certifying authority, that has to be signed by digital signature, and that is attached with public key, followed by certification authority identification, followed by user identification, and the complete complete packet of this certificate will be sent to the user. And there is a lot of protocols that has to be followed by the user. He should not tell the public key to somebody else, or he should not give the unique identification to somebody else for the other usage, and those will be liable under cyber law, and that will see in the last module of this lecture series. And basically, public key infrastructure functions can be mentioned like this. Until so far, we see what is certificate, and certificate standard format, and how the certificate process will go on and all. And now we'll see the basic functions of public key infrastructure. This is the public key infrastructure functions. The certificate has to generate, and he has to provide some storage for that. All the process of certificate is one of the prime function of public infrastructure. And key generation and key management is also one of the fundamental principle or function of public infrastructure, followed by periodic updation of the key, because the certificate will be not given for lifetime. There will be a validity, and if you want to check how the certificate given for Gmail or your Google and all, you can see with the help of the browser. You can right click at the internet logo, and there you can see the properties, and you can see the certificate and all. There will be a validity for that also. And certificate revocation is a process, long process. We'll see in the next upcoming model. Basically, public infrastructure architectures can be broadly divided into four categories. The first architecture is called as public infrastructure with single CA. What the meaning of CA? Certifying authority. And as we all know that the complete, I can give an example for this. The whole India we have many RTOs. We don't have single RTOs, and there we have to go. We have to go for DL test, and they'll provide the driving licenses. No, it's not like that. Each and every district, each and every taluk, there will be some RTO office. In the same way, here also, if we have a single C architecture, is one of the architecture where we have only one certifying authority, and all the users has to provide their certificate with the help of that CA itself. It's a tedious. Why it's tedious? Because previously we have only less number of users, less number of organizations where they used to use the certificates. But nowadays we have the as we see the digitization, the certificate users are very high. Hence, this is not at all valid for this scenario. And the major drawback of this is scalability. As the number of users increases, the single architecture fails to work. Hence, we are moving to a second important architecture called as hierarchical public key infrastructure architecture, where we have a centralized or the main person. As we in case of tree architecture, the initial node is called as root node, right? In the same way, here we'll call it as trust anchor, that is CA1, and it's a hierarchical. There will be levels, different levels of hierarchy, and the leaf nodes we can call it as anchors, and the root node we can call it as trust anchor. And we will follow a process called as oaching. Oaching is a mechanism similar to root traversal or tree traversal. In case of your tree structures, we used to traverse the tree to until the leaf node, right? In the same way, until the user, here also the traversing will be done, and that process is called as oaching. In this example, we have a CA at the level 0, and CA2, CA3, and CA4 at level 1, CA5, CA6, and all others users at the next level. If I see the first CA, if a user 5, let me take an example of user 5. If the user 5 want to authenticate, he has to contact CA6. In the diagram we can see there, correct? If the CA6 will be again authorized by CA3, and that CA3 will be again authorized by CA1, correct? This process is called as oaching process. Okay. And what is the major drawback of this? If something fails to work, if for example CA3 fails to work, we cannot able to oach back CA1. There will be a drawback. Okay. To overcome this drawback, we are going for next important architecture called as mesh-based public infrastructure. This architecture is similar to mesh architecture. Each and every CA will be connected. You can see the diagram shown in the below. CA1 is not only connected with CA3, it is also connected with CA2. CA3 is not only connected with CA1 or whatever, it is also connected with CA1, CA2, CA4, CA5, and CA6, and so on. This is the best architecture, and if something fails, intermediate nodes or in the tree, if some node fails in the hierarchy, if some node fails to work, the other will take care of the respective certifying authority. And why this architectures has been divided? Because initially we have it only one CA, and that CA has to provide the signature or the certificate for all the authorities. As the days goes on, number of users increases, number of organizations using the computers or resources are very high. So they went with different kind of certifying authority, and all these will be monitored by centralized authority represented by Government of India. And next important, the fourth important architecture called as bridge-based public infrastructure, and this is also a very important architecture where the centralized authority will call it as bridge CA, called as certifying authority, and it is going to maintain different levels like left and right, both wings. The left CA, again, it follows the principle of any other previous architectures. It might be though single CA, or it might be mesh architecture, or it might be any other architectures. Okay, that indirectly follows other architectures, other existing architectures. This mainly the bridge architecture will be commonly used for the organizations where they have sub branches. Let us consider an example like, for example, we have different taluks, and each taluk there will be RTOs. RTO1 for first taluk, RTO2 for second taluk, and those RTOs will be again subordinated and coordinated by centralized district RTOs. Correct. In the same way, here also we have, if we have some private organization A and B, and those will be monitored by centralized architectures. And this is also somewhat scalable, and it's provide best opportunity to establish certificates with the help of certifying authorities. These are different four different architectures of public key infrastructures. The next important process called certifying certificate revocation. As I mentioned in functions of public infrastructure, the fourth function was certificate revocation. Certificate revocation is nothing but withdrawing the certificates. Once a validity expires, we have to give back one more certificate, correct? Or something, somebody theft or some mischievous thing happened digitally on that particular certificate. The certificate has to be withdrawn, and he has to. That process is called as revocation because of different reason. The process of withdrawing the certificate is called as certificate revocation. What might be the reason for certificate revocation? Some of the reasons are private key stolen. If some mischievous thing happened and private key has been hacked by some attacker, and we have to revoke the certificate. Mistake in the information, some mistakes in the information or user identity or whatever, that have immediately the certificate has to be revoked. User leaves the job, or organization request for certificate revocation. For example, an user working in a corporate field, and he got a good offer and he will shift for some other company. He has to give back all the credentials. Why? Because the complete database was maintained with the help of same certificate. So before leaving the organization, he has to submit back all the things, and that time the certificate revocation will be happened. How the certificate revocation will be happened? By using two important mechanisms. One is called as offline mechanism, and second one called as online mechanism. How the offline will be does, as in case of ledgers. I think we saw ledgers in case of banking sectors, or any maintenance. We used to write all the names, person name, the identification number, in time, out time, and all. In the same way, we here also they used to maintain the things, and it's a very traditional fashion, and it is not at all used now. And they used to follow online certificates using some two protocols called as online certificate status protocol, simple certificate validation protocol. Using these two protocols, certificate revocation will be happened. And as I mentioned, CRL, called a certificate revocation list, maintains all the revoked certificates, which are the attacks happened or hacked happened, private key stolen, or some mischievous thing happened. All the data will be there. And OCSP, as I said, online certificate data protocol, which it's a coordination between it will be in the browser, and it's a coordination between certifying authority and digital certificate. That is, in the periodic time, the digital certificate should be sent to the certifying authority, saying that the certificate is valid or certificate is stolen, or whatever the update they have. That should be periodically update in case of OCSP. In the similar way, SCVP, called as Simple Certificate Validation Protocol, is an extension version of OCSP, where multiple certificates will be checked in a single attempt. That is the meaning of SCVP, and almost all certificate revocation nowadays will be happened with the help of Simple Certificate Validation Protocol. This is a lecture series on key management.